2-4 is kind of a longer lesson just because we want to give you lots of different stories to kind of work around here. This is a good one, and we'll get started with it today and see where we end up. So it says, now we turn our attention to studying the effects of alcohol. Blood alcohol concentration is a percentage of alcohol in the bloodstream. The legal limit for operating a motor vehicle in most states is 0.08. This means that 0.08% of a person's blood is alcohol. So the table here is from WebMD and tells how a person is affected with different BAC levels. So may pass out, tremors, memory loss, cool body temperature at 0.3, slurred speech, poor coordination, slow thinking at 0.10. Okay. So, okay. So let's move on to one. It says, after being arrested for driving under the influence, a well-known starlet was found to leave 3.5 times the legal limit of alcohol in her blood. What was her blood alcohol concentration? Okay, so it says she had 3.5. So 3.5 would be 3.5 times legal limit. And the legal limit is 0.08, right? No. Yeah, the legal limit is 0.08. So 3.5 times the 0.08 is 0.28. And that says explain exactly what your answer to question 1 means. Blood alcohol concentration was 0.28%. And 0.28%, she was almost ready to pass out, right? She was within passing out, memory loss. Crazy. Describe some of the effects the arresting officers may have been able to observe. So she would be close to passing out. What else? So she's above the 0.2, very much above. So probably trouble walking, double vision, nausea. She might be vomiting. What did it say? Double vision. Okay, so it says John Q, bonehead, decides it would be a good idea to drive when he shouldn't. Fortunately, he gets pulled over before anything tragic happens, and a BAC test finds a level of 0.16 at 2 a.m. Unlike most other drugs, studies have shown that the alcohol leaves the bloodstream at a constant rate. The table shows his BAC after every hour after the arrest. So we can put this data into Desmos, and it's asking what is the slope, what does it tell us, and what is the y-intercept? So I'm no longer expecting you to do anything by hand. I'm suggesting highly that we go to Desmos, create a table, and we put this data in. So we're going to at least get this in for the day before we leave, and then we can work on answering some of these questions here. Okay. So in my Desmos here, I'm going to put 0, 1, 2, 3, 4, just like they had, and then 0.15, 0.15. Okay. So we have this. I'm going to, you can see my dots, but not very well. So I'm going to hit my magnifying glass here. And you can see that it doesn't look like a perfect straight line, and it's not going to. Oh, and that's maybe because I typed in 0.15 and 6.16. There we go. It is a perfect straight line. Okay, we want to find the model. So we're going to, from now on, let Desmos do this when we have data. So to let Desmos do this, we have to use the whatever Y1 it has for us in Desmos. Mine has Y1, so I'm going to say Y1 and then tilde and then M for slope, whatever my Desmos has, which is X1 plus B for my Y-intercept. You can call M and B anything you want. I'm going to call them M and B because that's what we've been using. And I'm going to save this graph here. Oh, I'm going to go up here and no, I want to save my graph. It's not running. This is weird. Okay. Oh, because I'm not logged in. This is mean. So go ahead and get yours in, and then I'm going to save it. Now I can save my, I'm going to save mine. It's going to let me title it. So I'm going to say lesson 2-4 alcohol. BAC. Okay. And then I'll put this link in the recording in JetNet so everybody has it. Okay, so you can see that my R squared, which we said we're going to use, is a 1. The R is what we really want to use. The R tells us if it's negative, it tells us that it is a negative slope, and you can see that in the graph. And the 1 tells us it's a perfect relationship for linear. And our parameters are M is negative 0.015 and B is 0.16. So let's write that on our paper. For number 4, M is negative 0.015. And number 5, the y-intercept is 0, 0.16. Okay, so let's go back to our paper and just write out what these mean. So we have them. So for our slope, it's for everybody should be following this description formally how to write this. So for every 1 increase in, and this is where we're going to put our X variable. We're going to describe it in, and our X variable is hours after 2 a.m. we can expect the BAC to, and now I'm not going to say negative, I'm going to say to decrease, and that shows the negative, to decrease by, and this is where we enter Y. I mean, this is where we enter our slope. And our slope is 0.015. And then 5 says, what is our y-intercept? And there it is. And it says, what does it tell us? It tells us that John started with a BAC of 0.16 when he was pulled over at 2 a.m. That's what we're starting with. So let's put it all together, the equation here. So it says, write the equation describing John's BAC. So we're writing this with our parameters. So M and B. So y equals negative 0.015 x plus 0.16. So this is our model that we came up with. So number 7 says, when using an equation to model a situation, it's important to recall what specific information the equation provides. Restate your answer to question 6 in the form of a statement like this. If x represents blank, then y equals blank represents blank. It says, don't physically fill in the blanks, write a full sentence. So if x represents hours after 2 a.m., then y represents the BAC after X hours. Everybody with me so far? So let's answer 8, 9, and 10 so we can be done with this part. So it says we've learned about several features of graphing calculators. We've already basically done this in Desmos. We've been doing a lot in Desmos. 9 says, what would Mr. Bonehead's blood alcohol concentration be at 3:30 a.m.? Remember, eating greasy food won't change it. So at 3:30 a.m., we have to figure out how many hours after 2 a.m. that is. So 3:30 a.m. is 1.5 hours, right, after 2 a.m. So we're talking about x equaling 1.5. So we can go to our Desmos here and do a couple of different things. We could just grab, for this one, because we have a model, we could just grab this and go to where x equals 1.5, and we're getting really close. And there it is, 0.1375. 0.1375. I'm going to show you another way that's easier. If you just go to another line in Desmos and type, I want to know, oh wait, well, you could just type it, y, you could say your slope, which is negative 0.015 times 1.5 for the 1.5 hours, 1.5 parenthesis, plus your y-intercept, 0.16. That would be one way. Or you could, like I said, you could just go to your graph and drag it to 1.5. Sometimes it's hard to get right there to move your mouse just perfectly. But there we've got it. 0.1375 is the BLT, or BAC, not the BLT, the blood alcohol content. Number 10 says, how many hours would it take for his BAC to drop below the legal limit of 0.08? So that's when y is 0.08. It says, set up and solve an inequality to answer the equation. So I'm going to show you in Desmos. So in Desmos, we want the y to equal 0.08. So I'm going to type that line, and then notice down here, so I have to bring up my graph. You can, when you're in the graph, if you press your left mouse key, you can drag your graph wherever you want it. And so I did it just so I can see it better here. And I can click on this intersection point. So I can go to that button and see that it's about 5.3 hours before he gets to that legal limit. So approximately 5.3 hours. Paper, I'm going to write approximately with not an equal sign, but this is an approximation. 5.33 hours to get below the legal limit of 0.08 BAC. Any questions on that one? And 11, 12, and 13 are all going over things that we've already done in Desmos. So you don't even have to worry about those because we've already drawn the graph and we've already used the graph to answer some questions, and we've already talked about the y-intercept. Oh, it says, what is the x-intercept and what does it mean? Ooh, the x-intercept, that's a good one. So the x-intercept would be the x time, right, when he doesn't have any alcohol in his blood. So that's a good question. So let's go back to, before we end, let's go ahead and go back to Desmos for a minute. And we can again force our y to equal 0. So when we do that, I am going to zoom. I'm going to go up here to the top right. I can zoom in and out. So I'm going to zoom out for a minute so I can get to the 0. And I'm going to click on that button here, and it looks like when I do that, he's not going to be back at no blood in his alcohol, or yeah, alcohol in his blood until 10.67 hours. So one last share here. So 10.667 hours until there is no alcohol in his blood. And questions 14, 15, and 16 are asking you to sketch an example with a positive slope. So that would be something here, a positive slope, right, going uphill. And then sketch an example of a line with a negative slope. So this would be a negative slope going downhill. And then it says, can you describe what a line with a slope of 0 would look like? Okay. A slope of 0 it has to be like kind of walking across the floor in your room, right? Unless it goes uphill. So it'd be something that just looks like this. So the last problems that I have listed on the schedule are page 183, problems 1 through 17. And it's just a really big extension problem that I'm not going to work on because we're going to continue to get practice on